Umesh is a technology-focused IT professional offering vast experience, leveraging software engineering, agile software development, test automation, and DevOps methodologies to deliver highly effective and creative solutions to business and technology challenges. Moish would be speaking on chaos engineering. You can find more about Umesh on the below video, which will post in the chat if you want to go there. It is there in GTR Agile Test Alliance. So with this, a warm welcome to Umesh.
Hello everybody, good morning, good afternoon, good evening, wherever you are. Today I'll be talking about chaos engineering and particularly about chaos testing, how we as a tester, how we can contribute to in chaos engineering discipline. So I'll interest of the time, I'll just skip over my introduction. You can find me on LinkedIn or Twitter to know more about me. So in the next 20 minutes, 25 minutes, we'll cover what is chaos engineering, the principles, how does it help the organization, and what is the role of testing, and thus what are the tools, and we'll, if time permits, we'll see the chaos testing in action. So in the last month, in the end of last month, Amazon had a massive outage impacting their customers using the AWS Kinesis services, which is used for streaming data, and this is used by the various IoT devices or IoT platforms. So Alexa or iRobot Roomba kind of services were impacted, and in fact, Spotify was also impacted, and many other services were impacted, were freezing the millions of these smart devices temporarily. And there is a lot of news as well in the media about this outage and the way Amazon took half of the internet down. In fact, Amazon also apologized for the outage. Do you know why it was caused? It was caused because of adding the additional capacity to the Kinesis platform. They added additional capacity to the Kinesis server fleet, and that exceeded the number of threads allowed by an operating system configuration. And as the limit kept being exceeded, the cache construction kept failing, and then it created a storm of events, unlikely events, where from the front-end servers were unable to route the request to back-end clusters. And this totally, taken down the AWS infrastructure as well as other services which were running on this. And there was a very interesting tweet. A lot of people started blaming the actual devices, smart devices. My doorbell is not working. My vacuum cleaner is not working. My smart freeze is not working. So instead of blaming these devices, probably the fault happened with the assumption that the Amazon Kinesis service will always be up and running, and we can live with that instead of having some kind of a backup system in place when such unlikely events happen. So these devices become brick for a few moments or a few hours, and they were unable to, users were unable to use these devices. So how to avoid such situations, right? So as the organizations or companies, whether startup companies or enterprises, startup companies are cloud native by day one nowadays, and the enterprises are migrating their workloads to cloud native, containers and microservices architecture, right? So this brings a lot of complexity because the nature of microservices architecture is you build hundreds of different services which talk to each other in tandem, and provide you the scalability and the distributed nature of the system, where you can scale and up the systems based on the requirement, based on the demand, and based on the feature requirements and all that stuff, right? So when the microservices and the cloud native architectures are being introduced, it also brings a lot of resiliency requirements as well, because we are using different systems, different endpoints, different databases, and they are all working together. If you are a traditional data center company, or using a data center or using monolithic architecture, you might not have this challenge because you always have a single point of failure. But the companies or the organizations which are using the modern architectures, they always face this challenge. So Netflix introduced chaos engineering when it started its streaming platform, and the nature of platform was it has to support a highly scalable streaming platform, right? And millions of users across the globe using different, demanding different videos and different content, and it was built cloud native. And when you build cloud native software, you have very limited control on the infrastructure because it is managed by your cloud vendor, whether it's Amazon or Google Cloud or Azure. But you really need to make sure that whatever the infrastructure that you are using, it is highly resilient, or your architecture can support unlikely events. And in fact, Netflix had some issues in the beginning of when they launched this streaming platform, and they realized that they need to make this platform more resilient, and that can only be done by practicing the resiliency, by injecting the faults into the system, and then simulating such kind of events, right? So chaos engineering, by definition, is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent condition in production. So this is defined at the Principles of Chaos website. So Netflix, Amazon, LinkedIn, Google came together, and they kind of came with this discipline of chaos engineering, and they put up this website where you can find the definition of chaos engineering and the principles of chaos engineering. The chaos engineering is largely popular among the the companies which are adopting cloud-based architecture or cloud-native architecture. So what are the real-world events that cause our systems to break, right? So there are a number of events. It could be network faults, it could be a latency or slow internet. We can have DNS failures. We can have faulty server or network infrastructure. It could be an application issue. It could be DDoS attack, or it could be a natural disaster or fire at the data center. So when such events happen, how are we prepared? Old days, when we had a physical data center, we used to do a DR activity, disaster recovery. It is a kind of a testing activity, right? And to ensure that in unlikely event, our systems are still running and we are able to support our customer, or we have some backup mechanism to support the customers at a reduced capacity. So how do we simulate these events and how do we test our systems against these events? So this is not just about the events, solving the architectural problems. It's also about training our engineers, training our operations teams to deal with such system. It could be like the call center, how they can manage traffic. What communication needs to be sent out to the customers. So chaos engineering is much broader discipline. It does involve about building the resilient system, but it is about understanding your system, understanding the weaknesses, and then working and fixing those weaknesses. So in short, the principles of chaos engineering, there are 4 important principles about implementing chaos engineering discipline in any system or any place. Is about how do we simulate the real world event to understand how our systems react to those. For that, we run experiments and we inject different types of failures in our systems, right? Whether it's a production system or not production system. There are companies who have highly matured their chaos engineering discipline. They are able to do this in production. There are companies which are adopting and they are doing it in non-production environments. And then how do we automate this experiment and run them continuously? As the DevOps and CI/CD getting adopted at the organizations, how do we make it as part of our CI/CD pipelines? And how do we, when we execute or we run these experiments, how do we reduce the blast radius? Especially if you are doing this experiment in production, it should not bring entire system down. It should be done for a small set of users without knowing them that there is a such event happening. Many times you will see Netflix, you will see your recommendation page may get empty, or you don't see something there which you used to see. And probably Netflix is running a chaos engineering experiment behind the scene, right? But it should not be noticeable, or even if it is noticeable, then the customer should not have any impact. Now, why testing? Why it is what is the role of testing in chaos engineering? how testing teams or as a QA engineer you can contribute to this. I think you can contribute to this a lot in terms of just going beyond your functional and covering the much wider range of scenarios, both software and infrastructure. It's not just about testing whether a particular feature works, but what happens if unlikely event happen, how that feature should work, and how it should behave in an unlikely event. You find problems which traditional testing can't expose, because you are actually testing a running code in production, right? And then it can tell you a lot of different aspects or behaviors of your code. And your testing should be performed safely and effectively. So the chaos testing is becoming a emerging discipline in various organizations and important tool in your quality assessment toolbox. So what are the workflow of chaos testing? So I'll quickly run through this. There are majorly 6 steps. This is something that I got it from Gremlin, which is one of the vendors in this area. So first step is to identify the conditions that can go wrong with your system and list down those conditions. Then plan your experiment to simulate those conditions. And to simulate those conditions, you need to inject faults into systems. So you need to identify which faults, what are the risk or conditions that you want to execute, and what are the faults that are required for this. Then you need to define the blast radius in terms of, you first start with a small experiment and then you grow your experiments, right? Run these experiments and observe your systems. Apart from running the actual, injecting the fault and running the actual experiment, you should also have better observability and monitoring in your system to understand different aspects of your system. If that works, celebrate, and then again, if it didn't work, then go back to step number 1. And once you complete all your hypothesis, you can stop there and then make sure you can get into the next level of chaos engineering. So in order to perform chaos engineering, we need tools, right? Because simulating injecting fault like CPU, maxing out the CPU or covering the using the entire memory, it cannot be done manually so easy, right? So we need some tools, and in order to simulate these real world events, we need special tools. And good news is there are many, and most of these are free. Some of these they are commercial tools and they come with a lot of expertise. So the popular ones are Chaos Monkey, which is the tool that Netflix introduced. Then we have Chaos Toolkit. We have Mangle from VMware. And in the commercial world, we have Gremlin and the Chaos IQ. So you can find more about these tools on this awesome chaos engineering resource page. All the tools are listed there and links to them. So we'll be looking at Chaos Toolkit very quickly as part of this session. So in order to execute the chaos testing, as I said, we need to simulate the real world event. We need to inject the faults. And what are the different types of faults that these tools support? So there are 4 categories of faults broadly that these tools will help you. They will help you to simulate network faults, like simulating a low latency or packet losses or DNS blackout. They can help you with resource infrastructure faults where they use the CPU cycles. They will make it max out the CPU, or they will delete a resource or a disk. There is a state fault, which is shutting down a particular machine or shutting down a particular service. Or it could be application faults, we'll be using a Spring example later. So in Spring, you can inject exceptions or latency, or you kill the JVM. So the chaos engineering tool will help you to simulate these faults or inject these faults, not simulate, inject the faults and simulate the real world event. So let's briefly look at chaos engineering in action. How does it work? How the chaos testing works? So probably this week you might have seen this on various social media networks. Elon Musk and SpaceX demonstrated us the future of travel to Mars with the SN8 rocket, and they were successfully tested this rocket. A lot of people say that in the end the rocket was it was blasted and it was destroyed, but it was destroyed on purpose. And here is the interesting tweet that Elon Musk made. So he tells us that it was on purpose to collect the data, to understand uh, uh, what could go wrong, and collecting that data and using that data to find the next version of the rocket, or next release of the rocket. And then he also celebrated this with his team as well. So this is how Elon Musk and SpaceX is doing chaos engineering today. So okay, so coming back to the example that I want to run through, let's imagine that you are working on the ICC website, and it provides you different things like cricket rankings, team fixtures, and team compositions and all that stuff. So imagine this is an application running with different microservices, which are implemented in a Spring Boot framework, which is a Java MVC framework. And I'll simple demo of how we can inject a failure here. What we'll do is we'll break the connection between database and this particular service, which returns the ranking of cricket players. And in the first round, I'll show you this how to do it using Postman without using any automation tool, how to do it on your own. And for this, we'll use the Chaos Monkey for Spring Boot. It's a small tool that CodeCentric has released. It's an open source tool that you need to inject in your Spring Boot application in order to simulate or inject a fault and simulate an event. And it will lead to an error, and then how we can fix it. In the part 2 of this the demo, I'll be showing you the Chaos Toolkit, which is a automation tool, you can say, for simulating, injecting different faults and simulating the events. The Chaos Toolkit is an open source tool based on Python, and it's a command line tool that supports different drivers. For example, you can simulate different types of faults on AWS or Google Cloud or Microsoft or application technologies like Spring Boot, right? So it supports different drivers, and you can use this to automate your chaos experiments, and you can run these chaos experiments as part of your CI/CD pipeline. And in the second part, I'll show you how to automate that with Chaos Toolkit. Here we will use an experiment, a declarative file that we'll see, which is created in JSON format, and we'll use Chaos Toolkit to run that declarative file and simulate the same behavior. Right. So as I said, I hope you can see my screen and these bunch of code windows that I'll be showing you. So this is the Spring application, Spring Boot application that is running a simple REST API. What I have done is I have added a dependency, or I have injected the Chaos Monkey Spring Boot tool to simulate or inject the faults and simulate a particular event, which is the database connectivity is lost. For that, we also need to do, in Spring Boot, we have to configure certain properties, which I have done here. And this is the service that is running. At the moment, the service is running with a fault, but without injecting the fault, and it is returning some results from the backend. Now, what I'm going to do is I will use the Postman collection which I have created. So I'm going to make certain requests. In Spring Boot, we have something called actuator, and then using actuator, we can instrument a Spring Boot app, which means that we can play with the Spring Boot application configuration at runtime, and we can find out the various metric, as well as we can set up certain things within the Spring Boot to try different experiments. So as I said, I'm going to use Chaos Monkey to inject a fault in this particular application, which is going to create an exception called connection timeout when it connects to the database, which means that we are trying to simulate a situation where database connectivity is lost, and then we want to understand how application behaves. So if you look at the base state, in a normal condition, it returns a list of players with status code as 200. Now, what I'll do is I'll use the chaos monkey. I will enable the chaos monkey in the application which is running on my computer. This will enable the chaos monkey. I also need to set certain watchers because the chaos monkey will look at different requests that are coming to the application, and then it will inject the fault into the application. And then I'm going to inject a fault. So here fault, I'll show you what I'm trying to do here. So here I am going to inject a fault which will simulate an exception called connect exception, and it's going to return connection timeout exception whenever the application connects to the database. I'm going to inject this fault now. The assault or the fault is configured in the application. So application is still running behind. And now if I request the list again, I'm going to get error, okay? Because my developer might have not handled this situation really well. So the exception is not handled by the application. Or probably there is no caching mechanism handled when such event happens, for users to get whatever the last list that they have seen. So this is the fault has helped us to identify this problem. And even if you go back to the Postman, it is going to return you some error, right? So this particular fault has helped us to identify the issue that the exceptions are not properly handled in the application. And when in the real world, when database goes down, this is going to create a problem or a bad experience for the user. So how do we fix this, right? So I'm going to do a temporary fix by adding an exception, but we also need to recommend to our architect that we need a caching layer where the list can be seen. Whatever the previous cached list can be given to the user. All right, so I think I
One more thing, Umesh, if you can wrap up in 2-3 minutes, it would be great.
Okay, all right. So I'm about to close this. So now this we did manually. Now I have to do this automatically in an automatic fashion. Then how I can do this? So I'll just disable this for a moment. So I talked about Chaos Toolkit. So in Chaos Toolkit, we can simulate this exception by creating an experiment. So it is a declarative file that we need to create, and we need to tell what is the steady state hypothesis, which means that the player data should be available. And it should return as the list of the players, and it should return status code as 200. And then we inject the chaos. The steps that we seen in Postman are configured in this particular experiment file. And this is a file that we create. And now we are going to run this in a command line. So the chaos toolkit, there is chaos, the Python package needs to be installed, chaos toolkit, to run this experiment and then get the outcome. So I'm going to run this very quickly. And this particular experiment is failed because, as I showed you in Postman and in the browser as well, the exception is not handled by the developers in this application, right? So I'm going to fix it very quickly. So I'm going to introduce a little exception handling here. So whenever there is an exception where the database connectivity is lost, we can send an empty list of array. Just a moment, let me restart the application. All right. Okay, so we'll come back here and the application starts. Great. So the application is up and running now, and I'm going to run the same experiment, but in this case we have fixed an finding. We have added an exception. Sorry, just a moment. And in this case, the experiment is passed, which means that we are able to recover the application. It is retaining an empty array, but we can have a caching mechanism. We can make this recommendation to our architecture team to implement a caching mechanism in this application. Right. So coming back to the presentation, we can use the chaos toolkit to scale this our chaos testing. We can cover multiple services. We can simulate different faults, so the database connectivity or particular service going down or a database going down. So you can do a lot of things with different drivers that chaos toolkit offers. All right, so to sum up this, how does chaos testing helps? So most importantly, it helps us to identify the weaknesses in our application when we run this code in the runtime. It will help us to reduce a lot of incidents. It will help us to reduce the cost of downtime. So if you look at Amazon stats, they spend millions of dollars every day if the production their systems go down, right? We can train our team, prepare them for such events happen, how to address this, how to manage this event, and how to resolve these issues. So it's a great discipline to build more resilient and high quality systems. So that's pretty much for today. Thank you for attending the session.
So there are questions which have appeared. So Kshitij is asking a question on this. I think you can answer it directly.
Yeah. So see, if you are new to chaos engineering, probably you should start with your non-production or staging environments where you can start with small experiments and gain better understanding of your system as well as how to run these experiments. And as you mature, you can start doing that in production. But you need to ensure that you have the rollback strategy in production. And as I said, you need to define your blast radius. You should start with small, and then based on your maturity, you can increase that blast radius.
Okay.
Does it come under performance testing or similar to it? In performance testing, probably we run the workloads for ideal benchmarks or to understand the breakpoint. It is similar, but the chaos engineering as such is running in production. In fact, it complements performance testing complements chaos engineering experiments. So we do a lot of performance testing during the chaos engineering experiments and gather a lot of data to fine tune our systems.
So yeah, I think you can see two questions from Shweta. So how often should we conduct it, and what are the minimal technical prerequisites?
Yeah. So chaos testing, I mean, you should do it pretty repeatedly. Keep experimenting your system as much as possible. You can arrange game days as well. You can dedicate certain days where you will do this experiments and gather everybody to do this testing. And if you're new, you can start with small hackathons and then make it more of a regular activity. Technical prerequisite, it needs certain, certain faults need you technical understanding of the systems, but you can build that knowledge. It's not something that it demands the technical skills immediately. So you can build your knowledge based on doing small experiments and understanding your systems. So I think the testers can learn from this. If they cannot contribute to technical aspect of it, they can contribute to designing the scenarios, identifying the blast radius, and whatever the data that is collected from this experiment, they can use it to designing their tests better.
I think thanks Umesh for your really wonderful session.